Hey everyone, so today we're focused on chapter 11, section 2, and this is problem number 2 called U and I. And so we're looking at the difference between linear functions and quadratic functions. And the major difference between these two kind of functions are their rate of change. Now in a linear function we know we have what's called a slope, which is a constant rate of change. So if I do what we refer to as the first difference of each coordinate point, meaning for all my a of x, I'm just saying what is the difference between those two coordinates. On a linear function, I'm going to get the same difference throughout my data, whereas on a nonlinear function or a quadratic function, I'm going to get different differences, so to say. So for problem number 1, it says, which table do you think represents each type of function? And explain your reasoning. Well, table A is linear because the rate of change is constant, or that first difference is the same, right? I'm decreasing 0.25 between each y coordinate. And in table B, I'm looking at a nonlinear or a quadratic function. And I can determine that because the rate of change, or the first difference, they're changing between each coordinate point. It's not constant. So again, I'm getting that information right from my data table. Now, problem number 2 asked me to calculate the first difference for each function and describe the patterns that I noticed. Now, this is something I just completed just by answering problem number 1. So I'm going to go through and just write that in words. Moving on, we're going to take a look at problem number 3. And we're discussing the graphs of the two functions. So first of all, I want to identify the graphs that represent table A and table B. Obviously, table A was linear. Table B was nonlinear. So the functions are going to reflect that as well. The linear function does not have any exponents, while the nonlinear function does have exponents. So I can also confirm this in my calculator if I wanted to graph both functions one at a time, see which one appears first, and that would also confirm those graphs for me. We're going to look at problem number 4. It says describe the rate of change for each graph. Again, going back to the data tables in problem number 1, we described table A as having a constant rate of -1/4 or -0.25. And table B had a rate of change that was fluctuating. We weren't really sure exactly what it was. If I look at the graph of table B, or function B, I can actually calculate the slope pretty quickly by doing a rise over run in between a series of data points. And I can see by doing that my graph is actually going to be symmetric. That quadratic function is a symmetric parabola, which means the rate of change will repeat in opposite form. It just depends where the graph is positioned. So that function B has a fluctuating rate of change. It is, symmetric, but it's not constant. And number 5 asks for the y-intercept. Again, we're just seeing by observing the graph, but also by examining the function, because for the function of the linear equation, it's -1/4 x plus 7. We know y equals mx plus b, 7 must be the y-intercept. And then that quadratic, we're just examining on the graph as well, because it's 0. Number 6 says identify the leading coefficient in each function. Then describe how the sign of the leading coefficient affects the behavior of each graph. So for function A, the leading coefficient is -1/4. The negative sign means that there's a negative slope of the line. So that tells us that on the left-hand side, the line is going to be higher up, and on the right-hand side, the line is going to be farther down. For function B, again, we have a leading coefficient of -1/4. The meaning of the leading coefficient in a quadratic function the sign, positive or negative, determines whether or not the quadratic opens upwards or downwards. So a negative coefficient opens downwards, just to clarify. Problem number 7 asks us to calculate the second difference for each function. So again, we need to go back to problem number 1 and look at our initial differences, and then calculate the difference between those differences. So it's a second level of difference. For table A, it's 0. For table B, it's a constant, which is 0.5. So that's actually something interesting. That's going to help us determine what kind of linear function we're looking at. So when we examine an equation, we use the given x values to evaluate the function and solve for y. Then we use the y values to determine the first difference. So for example, I'm doing -4 minus -6 is 2. -2 minus -4 is 2. 0 minus 2 is 2, right? So I have all my first differences. Then I do my subtraction of my first differences to achieve my second differences. So letter A and letter B, I'm kind of doing out quickly for you. This is just subtraction. This is nothing complicated. It's no kind of magic. But when I get 0 second differences, my equation or my function is linear. When I get constant second differences, my function is nonlinear or quadratic. So let's pause the video right here. Try these two functions independently and tell me whether they are linear or quadratic. So obviously I fast forwarded a little bit through those responses, but letter C was linear and letter D was quadratic. Now looking at problem number 2, what do you notice about the first and second differences in linear functions? The first differences are the same and the second differences are 0. And in quadratic functions, the first differences are different and the second differences are the same or constant. So it's a really nice pattern to be able to observe. Now problem number 3 says sketch the graphs represented by the equations in question number 1. Now I'm sketching my graphs, and here's the thing, all I'm doing is plugging in an x value, like x equals 0, x equals 1, x equals 2, and solving for y. I'm just evaluating that function in my head. So as I proceed, you're going to see that some of these equations are linear and some of them are quadratic. And you should be able to simply calculate an output value for each input value you assign to that function. So the next thing we're going to do is just look at problem number 4 quickly. And we're going to make some observations about first differences and second differences for linear and quadratic functions. Obviously, if the difference is positive, it's increasing, negative is decreasing. And for the quadratic, there's kind of two stages here. If it's a first difference and it's negative, it's decreasing. If it's a second difference and it's negative, it's opening down. If it's a first difference and it's positive, it's increasing. And if it's a second difference and it's positive, it's opening upwards. So by doing first and second differences of function tables, we can really determine the shape and the direction of any kind of function.